As discussed in the report, and for this demo, the project is running on a DigitalOcean VPS with the front end on Vercel and the database via Neon. Within the system, there are three groups of users. Advertisers. These are companies or individuals that create and fund advertising campaigns. A single advertiser can manage multiple campaigns, each defined by a budget, creative assets, and specific targeting constraints. Publishers. These are website owners who integrate the platform to provide space for advertisements and facilitate the collection of user fingerprints. They have both revenue from the platform and access to detailed user analytics as incentives to run ads on their sites. And finally, end users. These are individuals who browse the publisher websites, and as they navigate the network, their anonymized browser fingerprints are collected, and they are the target audience for the advertisements. The dashboard uses role-based access control, meaning only authenticated advertisers can access the advertiser pages and vice versa. Creating an account is simple, with passwords securely stored. After logging in, a custom notification confirms this was successful. This new advertiser account has no spending power, so cannot fund a campaign. Let's top up the balance. The billing page is where an advertiser can fund a campaign. Whilst in development, the system is using the Stripe sandbox environment, which can be swapped over to take real funds. We will top up £50, which should be plenty. Entering valid card details from the documentation and my university email address, a top-up has been made. Stripe automatically handles fraud detection for us, and we can now see the outcome of the transaction as a success. Stripe's dashboard confirms the payment went through and an email receipt has been sent. Activity from all three user groups is tracked to create detailed activity logs. Both publishers and advertisers can view financial transactions related to their accounts in the dashboard, or alternatively generate a PDF for external record keeping. Now that we have some spending power, let's create an advertising campaign. For demo's sake, let's pretend we are Sports Direct. We enter this name, and a link end users will be taken to when clicking on an ad placement. Next, we need to enter some key terms that we can use to help target our audience. The drop-down menu gives some suggestions, and we need a minimum of 10 to continue. Later, this can be edited. Using the two sliders, we can select how long we want the campaign to run for, and this will automatically adjust the maximum daily spend to align with our account's spending power. Let's assign £30 to run for 10 days. The campaign needs some media associated with it. This media is then served to end users as advertisements. In Figma, I created a selection of example adverts that promote the system itself. Let's attach one of these to the campaign we just made. Uploaded media can be found under the library. Media can be associated with multiple campaigns or none at all to be used at a later date. Clicking an item allows for edits to be made or change campaign participation. Media can range between images, GIFs, or short videos. Back on the home page, we can see our freshly created campaign and recently uploaded media. Let's click on it. Here we get a detailed view into the new campaign. The campaign is currently paused, so not part of the active campaign pool. This means ads cannot be served from the campaign till the advertiser enables it. As previously mentioned, the target demographic can be adjusted along with interest keywords. Spending insights, transaction, and advertisement performance can all be reviewed. The two custom chart components track the click-through rate of the campaign over the last 7 days, hence the flat line. Let's set the campaign to active. Navigating to an invalid page will return a custom 404 where a user can safely return back to the login screen. Let's now register a publisher account. With a similar dashboard to advertisers, but rather than creating an advertising campaign, we instead want to set up ad placements onto our website. The publisher homepage shows recently integrated websites, daily earnings, and the status of any withdrawal requests. To assist getting started, the documentation page provides step-by-step instructions. The sticky Quick Find menu aids in navigating the docs. Having read through the docs, let us now set up the publisher website. For example's sake, an energy drink company. The website domain is what is hosting the publisher content and where ads will be served. I own srs.codes, so we'll use it for the example. Similar to an advertiser, the publisher also enters demographic-related data. A verification code is then generated. To verify a website, the publisher must enter the unique code into their domain's txt DNS record. This can be verified now or at a later date, but to complete integration, verification must be done. Following the intuitive example in the documentation, I enter the verification code for the domain srs.codes. After the minimum time to live of 10 minutes, the website ownership has now been verified as ours. Now the website has been verified, we must specify what pages of the site we wish to have ad placements. We enter the type of adverts per page, such as rectangles or pop-ups. The more pages entered, the more detailed analytics can be taken about how an end user interacts with the website. Snippets of code to integrate this into the publisher's website are generated, with more details found in the documentation if any more help is needed. When an end user visits a publisher website, this is an impression. Advertiser campaign funding pays for each impression per advert served from their campaign directly into the balance of a publisher's website. Once the minimum threshold has been met, the publisher can initiate a withdrawal request, taking funds from their website's balance and off-ramping to real money. To comply with AML, they must undergo KYC. My report outlines how end users are distinguished by one another through device fingerprinting. To view how your device fingerprint is constructed, a page of the dashboard was created. This is the first time interacting with the system, so my device is not recognized. But after reloading and visiting a second time, the system now recognizes the fingerprint again. Complying with GDPR, an end user only needs to navigate to the Delete My Data page, and all of the data associated with their fingerprint is deleted from the system. The settings page for both advertisers and publishers facilitates account deletion. The Royal Holloway simulation page was set up to compare methods of advertisement recommendation as outlined in my report. Here, any of the variables of the simulation can be adjusted and configurations saved and loaded. Running the default configuration, we can successfully compare the methods of recommendation. The plotted graphs show the simulated click-through rate and an overview of each campaign's performance. Whilst less favorable to the machine learning method of recommendation trained on obfuscated data, recommending advertisements from inferred interests is favorable to randomly serving them, successfully accomplishing my initial goal. The activity service class records data about every interaction. This includes how advertisers and publishers use the dashboard, and as an extension can be used to A/B test and improve dashboard interaction. Furthermore, a machine learning model trained on end-user data, such as publisher website activity and ad placement interaction, would be the next logical step for this project. Finally, I set up an example page on the dashboard that uses the custom SDK to inject the example adverts into a fake website. Clicking these adverts takes an end user to the dashboard, successfully advertising the system to potential advertisers. Thank you for listening.